Okay, so now we are going to take what we know about zeros, and we are going to look at a polynomial and try to determine what the particular zeros of that polynomial function are. Now, I have a polynomial function that we're going to use for this. So this is f of x is equal to 6x to the fourth minus 37x cubed plus 53x squared minus 2x minus 8. So there's my polynomial function. I want to see if I can determine the zeros of this polynomial function. Now, we cannot find complex zeros or irrational zeros directly, but sometimes we can find those at the very end if there are only two of those, by first finding all of the rational zeros, because we can find the rational zeros. So first I want to talk about what are the possible rational zeros for this function. Well, the possible rational zeros for this function are determined by taking all of the factors of your constant and dividing them by all of the factors of your leading coefficient. So all of the factors of 8 are plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. And I'm going to divide each one of those by the factors of my leading coefficient, my coefficient of my highest degree term. In this case, it's 6. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So if I wanted to list all of the possible rational zeros for this particular function, then of course I'm going to put each one of these over each number here. So let's start with putting them over 1. If I put each one of these numbers in the numerator over the 1, and I'm just going to list them over here, but they're kind of out of the way, then I would get plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Now, let's take each one of these numbers and put over the number 2. Well, when I do that, I get plus or minus 1/2, 1 over 2. 2 over 2 is 1. I've already got that one listed. 4 over 2 is 2. I've already got that one listed. And 8 over 2 is 4, and I already have that one. So I'm done there. So now let's put each number over 3. All right, plus or minus 1/3. And then 2 plus or minus 2/3. And then 4 plus or minus 4/3. And then we'll put the 8 over 3, so plus or minus 8/3. All right, now I'm going to put every number over 6. Well, plus or minus 1 over 6. 2 over 6 is 1 over 3. We've already got that number. 4 over 6 is 2 over 3, and we already have that number. And 8 over 6 is 4 over 3, and we already have that one. So these are all of the possible rational zeros. All right, well, I want to start eliminating some of these. So I'm going to use Descartes' rule of signs. Now, Descartes' rule of signs tells me how many positive real zeros I can expect and how many negative real zeros I can expect. So first I look at the sign changes in the original function. All right? In the original function for f of x, then this is a positive and that's a negative. So there's one sign change. Negative to positive, that's 2 sign changes. Positive to negative, that's 3 sign changes. Negative to negative, that's not a sign change. So I have 3 sign changes in my original expression, and 3 sign changes indicate that I have either 3 or 1 positive real zero. All right, now to get the number of negative real zeros, then I find the signs of f of negative x. If I put negative x in for all of those x's, negative x to the fourth minus 37 negative x cubed plus 53 negative x squared minus 2 times negative x minus 8. Negative x to the fourth is positive x to the fourth, so we have 6x to the fourth. Negative x cubed is negative x cubed. Well, negative and a negative is a positive, so that becomes positive 37x cubed. Negative x squared is a positive, So I don't change my sign here. Plus 53x squared. Negative x times negative 2 is positive. And then I have my minus 8. So if I count my sign changes here, all I have, everything's positive until I get to here, so all I have is one sign change. So one sign change in f of negative x indicates that I have one negative real 0. So my possible zeros here are that I can have, I'm going to make a little chart. I can have 3 positive zeros, and I will have 1 negative 0. It's a 4th degree polynomial, so if I have 3 positive ones and 1 negative one, then I don't have any complex ones, because that's 4 zeros altogether. But if I only have 1 positive real 0, and here again I have to have 1 negative real 0, that's my only choice. So 1 negative real 0, then that leaves 2 complex zeros. Remember that your complex zeros come in pairs. You will always have 2, 4, 6, 8, 0 of those. Never an odd number of complex zeros. So this is what I'm looking for my polynomial. Now, in order to find those zeros, then I'm going to use this list. I've got mostly positive real zeros, probably. So I'm going to start to narrow the field and try to find those. I'm going to go ahead and erase this. I'll leave my little chart up here to remind me of what I found. I'll leave my possibilities up here. Alright, so here's what I'm going to use synthetic division. I'm just going to pick a number. Let's pick the number 2. Alright, and let's see if 2 is a 0. Now all I'm doing is listing my coefficients up here because I'm going to do synthetic division to determine whether or not 2 is a 0. I'm assuming that you understand synthetic division. Don't forget that if your polynomial is missing any terms, you must put a 0 in for those missing terms up here when you do the synthetic division. So the first thing I do is bring down my 6. 6 times 2 is 12. Negative 37 plus 12 is negative 25. Negative 25 times 2 is negative 50. 53 minus 50 is 3. 3 times 2 is 6. 6 minus 2 is 4. 4 times 2 is 8. And 8 minus 8 is 0. So sure enough, because I got no remainder, 2 is a 0. Alright, so one of my zeros is the number 2. Alright, well let's try another number, only this time I only have to try it with what's left. If x minus 2 is a factor, then the remaining factor is 6x cubed minus 25x squared plus, I'm going to have to write this down here, 3x plus 4. That's my remaining factor. So now I can just work with this and try to find the zeros that are a part of this. Well, let's try the number 4. Alright, so if I try the number 4, then I'm just going to use this part of my answer. We'll use my quotient. Alright, so I bring down my 6. 6 times 4 is 24. Negative 25 and 24 is negative 1. Negative 1 times 4 is negative 4. Negative 4 plus 3 is negative 1. Negative 1 times 4 is negative 4. And again, I've gotten lucky. My 4 minus 4 is 0. I found another factor, another 0. So I now know that 2 and 4 are zeros. And in order to get the zeros from here, this is a quadratic. 6x squared minus x minus 1. I can use the quadratic formula to find my other zeros if this is not factorable. And it may be factorable. Let's go ahead and use the quadratic formula. So the quadratic formula, negative b, so it's 1, plus or minus the square root of b squared, which is 1, minus 4 times 6 times negative 1, over 2 times a, which is 6. So 1 plus or minus the square root of 1 plus 24 over 12. Well, this is going to be 1 plus the square root of 25, plus or minus the square root of 25 over 12, which gives me 1 plus or minus 5 over 12. Well, that gives me 6/12, which is 1/2, and negative 4/12, which is negative 1/3. So these are my other zeros. So there are my zeros for this polynomial function. I was able to find them all. You aren't always able to do that, but this time, because we only had rational zeros, we could find them all. All right?